Today we are going to discuss parallel ladder. This topic comes from computer organization and architecture. Before parallel ladder, the concept of half adder and the concept of full adder should be very clear to you. Only then we can understand parallel adder. If you have any doubt in half adder and full adder, you please go through my video available on YouTube channel. Now, what is parallel adder? Parallel adder is a combinational circuit. Parallel adder is not a sequential circuit. Parallel adder is used to add binary digits in sets. A sets of binary digits are added by parallel adder. We know very clearly that half adder is used to add 2 binary digits, whereas full adder is used to add 3 binary digits. But in real life, what happens? We add a set of binary digits. We can only understand parallel adder very clearly if we take the example. We have the example in front of you. You can see that here we want to add 11 with 14. When we send the 11 and 14 to the computer to add it, firstly the computer will convert 11 into the binary digits, and the binary digits of 11 is 1, 0, 1, 1. Then computer will convert 14 into the binary digits, and the binary digits of 14 is 1, 1, 1, 0. Now, how the computer can add this set of binary digits? We have learned only half adder and full adder. Half adder can add only 2 binary digits, whereas full adder can add only 3 binary digits. So we need a special type of circuit which is known as parallel adder. Parallel adder is an organized combination of half adder and full adders. We need one half adder and we need a lot of full adders. We can take the example here on the board that we have one half adder, then full adder, and full adder. Now, just to get a brief recap about half adder, what happens in the case of half adder? Half adder takes 2 inputs and produces sum and carry as output, and full adder takes 3 inputs and produces sum and carry as output. Look, the first half adder, here we have 2 input lines because the half adder has only 1 input line, and it produces 2 outputs, sum and carry. What we are doing here, the carry is connected with the input line of the full adder. Full adder has 3 input lines. The first line is connected with the carry line of half adder, and the full adder will also produce sum and carry. You see, carry is also again connected with the input line of the next full adder. This line will also produce sum. Full adder will also produce sum and carry. The carry of this full adder is also connected with the first input line of this full adder, and the sum line and the carry line of the last full adder is sent as a output of the parallel adder. So this parallel adder has 1, 2, 3, 4, 5 output lines. Look how it processes our data. This is the first set, 1 and 0. The 1 and 0 is sent to the first adder, half adder. When 1 and 0 is added, what happens? The sum line will produce 0 and the carry line will produce, the sum line will produce 1 and the carry line will produce 0. This carry will be sent to the first input line of full adder. Now, the second set is added, 1, 1. 1, 1 is sent to the input lines of the first full adder. Look, the full adder has 3 input lines 1 is taken from here, and this input line receives the data from the carry line of half adder. So when full adder receives 1 1 0, what happens? The sum line will produce 0 and the carry line will produce 1. This 1 will be sent to the first input line of the next full adder. Now the third set of data is sent to be added 0 and 1. Look, when 1 0 1 is sent to the full adder, what happens? The sum line will produce 0 and the carry line will produce 1. This carry will go to the first input line of the last full adder. This is the last set of the data to be added. 1 1 1 1. When full adder receives 1 1 1 to add, what happens? The sum line will produce 1 and the carry line will also produce 1. Now, because it is the last full adder of the parallel adder, so the carry line will also send as output. Now, what is the output we receive? We receive 1 1 0 0 1. 1 1 0 0 1. When we convert this binary data to the decimal, we get 25, and we know that when 11 is added with 14, the 25 is the correct result. So parallel adder is nothing but an organized collection of half adders and full adders, so that it can add the binary data in a sequence. A sequence of binary data is added all at once. So simple. I hope you understood this topic, and thanks for joining this session. See you in the next video. Thank you. Bye-bye.